Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is, we understand in our previous class what are the various different kinds of technologies which we are used for the problem statements which we understand. So, what kind of technologies are helpful for getting the desired properties of the soil as per the construction requirements. So in this class, we will see few more different kind of practical solutions, what they are involved in this particular, based on the mechanical modifications. What are the mechanical modification techniques are helpful in various point of views of the soil properties. So in each kind of technology has their own kind of enhancement in the soil property. So in that, we are going to understand the various kinds of problem statements in this particular session. So in this, we are tasked with improving the ground of new shopping mall construction. So that is going to the construction is the shopping mall construction, that to new one. So shopping mall construction is the project. So this is the project. So according to this projects, what are the requirements are what kind of requirements are desired for this soil for getting the safe and economical construction work of this shopping mall. This is the motto, whenever we are using the ground improvement techniques. So in this, the site consists of a soft clay. Whenever we are constructing this kind of project, in that the type of soil is soft clay, which are going to, there is a chance to settlement. So to exploit this consolidation and increase soil strength, preloading with surcharge will be used. So in this case, what we required is the desired property. What we required property is consolidation. For this consolidation, as a part of mechanical technique, we choose this preloading with surcharge will be used. This is the technique we are used. These are the things first we are understanding. And also in the property which we are going to increase, that is consolidation as well as increased soil strength. So the increase in soil strength is also the parameter in this particular thing. So the preloading with surcharge will be used, and also the project shopping mall that is the, it depends upon the type of soil is soft clay. So in this, we are understanding what are the design considerations are involved and what will be the final outcome we will get from using this kind of technique, that is the consolidation and also the increased soil strength. Now we are considering that is the problem statement. What are the parameters which are going to involved in this particular, that is project shopping mall construction. Soil type is soft clay and layer thickness is 10 meters. Required settlement is equal to 0.5 meters and the surcharge load is 30 kPa. Time for preloading is 6 months. So for these are the parameters which we are going to understand in this particular problem. So here, the first thing what we do in any kind of construction, that is the site assessment. In this, conduct soil borings and laboratory testing to determine the soil properties, including the coefficient of consolidation and the compression index. So assume 0.5 meter square per year, that CV, and the CC is the 0.25 and the initial void ratio is 1.2. These are the parameters which we are understanding based on the soil properties. We are conducting the required laboratory test for understanding the soil properties. So here the settlement calculation, yes, due to the preloading is, this is the formula. So S is equal to CC H delta and 1 plus E naught. These are the parameters which we are going to understand. In this, the H is equal to thickness of the compressible layer 10 meters. Increase the vertical shear stress surcharge load 30 kPa. This is nothing but the compression induction and also initial void ratio. These are the parameters involved in this settlement calculation. So in this settlement calculation, we know about those properties and their numerical values. We are going to find out using the laboratory test. Some tests we are going to conduct for understanding those kind of parameters. And here that we induced this S is equal to, and we introduce and we replace them all in the numerical values into these parameters. So after calculations, we will get this value that is equal to settlement calculation 34.09 centimeters. So first we are understanding the what are the things, what are the required properties for getting the desired properties. So for that purpose, we are understanding, we are collecting the sample from the location and we are conducting the laboratory test to determine the soil properties, including coefficient of consolidation as well as the compression index. So once we are getting those values, we are going to find out the settlement calculation. So these settlement calculation due to preloading, this H is equal to thickness of the compressible layer, delta sigma. This delta sigma is the increase the vertical shear stress, and the surcharge load is 30 kPa. And the compression index, the value is equal to 0.25. Initial void ratio is equal to 1.2. These are the things we used. We are getting this settlement calculation. Now time to calculate the time calculation using Ted-Jay's consolidation theory to estimate the time required for 90% of the consolidation. So 100% consolidation, it's difficult. It is somewhat difficult. So 90% consolidation, for this we are finding this time calculation. Here the time factor is for the 90% consolidated approximately 0.848. The coefficient of consolidation is already there, that is equal to 0.5 meter square per year. And the time in years, the HD is nothing but the maximum drainage path 5 meters assuming the double drainage. So in these, rearranging these for the time calculation T. So now how much time it is required in years or in months, we are going to calculate using this formula, that is equal to TV divided by HD square. Here the time factor for 90% consolidation, that is equal to 0.48, and this coefficient of consolidation is equal to the 0.5 meter square, 0.5, and the time, this is the thing we are going to find out. This maximum drainage path 5 meters, and we converted into the centimeters, that is equal to 0.5. And finally, we will get 42.4 months. We are going to convert it is in terms of years also, that is equal to 42.4 divided by 12, that gives the in terms of years. We are getting the answer. We are divided by this, and what is the answer we will get, that is in terms of years. So like this we are going to calculate the time calculations. For the given problem statement, here they are asking how much for this we are getting these much time. So it may acceptable or not acceptable, it depends upon the construction, when we are going to start that construction, and construction schedule is satisfiable or not for this particular number of years. For getting the consolidation, we are kept all these parameters in this, and we are going to decide the which kind of technology is more suitable for these conditions. Now one more kind of technology we may understand in a problem statement point of view, that is soil mixing. In this technology, for a few industrial facilities, the foundation soil consists of loose and sandy soil with low bearing capacity. Soil mixing with cement is chosen to enhance the soil strength. So here in industry facilities, the foundation soil consists of loose sandy soil. So this is the type of the soil. It means it is in the condition of lower bearing capacity. So now we are going to increase the soil strength in soil bearing. Soil strength increases is required in terms of bearing capacity. These are the major points which we are going to understand according to this problem statement. That is, project industrial facility foundation, soil type is loose sand, and depth of improvement is required till 8 meters, and the cement content is 10% by mix weight. Average coverage is equal to 1000 meter square. So for 1000 meter square area, we are going to choose these cement content 10% of by weight. These are the things for mixing the soil mixing technology we are choose. So in this, we are going to assess the what are the required soil properties for improving the depth. We are find out using the some laboratory test. So we'll get the desired properties. We are understanding the what are the properties involved in this. The cement requirement calculation. Calculate the volume of the soil to be treated. That is equal to volume is equal to area into depth. That is equal to 8000 meter cube. And also assume the dry density of the soil is 1.6. That is nothing but the 600 kg per meter cube. So this is the dry density of the soil. Move on to the weight of the soil. That is equal to volume into dry density. That is equal to, after the calculation, we will get this much value. So now cement requirement by weight. So we are calculating again these in terms of tons. So finally that is equal to 180 tons. Now we are move on to the next step is the mixing process. In this soil mixing, first we are understanding the what are the soil properties, in what way that the properties are going to enhance, and we are going to which type of mixing material we are choosing. According to that we are calculated those mixing material requirement. Here we choose that is as a cement. So how much cement is required for this cement mixing, this soil mixing? That material is going to mix into the soil. That is nothing but the soil mixing. How much material is required for that purpose we are calculating in this particular step. So once we understand the quantity of the cement is required for the mixing of the soil for getting the desired properties. Now the process, how we are going to mix, how we are getting these, we will go through. So once we understand the how much cement is required, once we know about the what are the various properties involved in that, and also the what are the various cement requirements in this, now the mixing, use a deep soil mixing ridge to inject and mix the cement into the soil. So now once we understand the soil properties, and we are going to move on to the what are the various things are involved in this requirement, how much according to the percentage we are calculated the required material. In this case that is cement. Now the mixing procedure, use a deep soil mixing rig to inject and mix the cement into the soil. So according to the type of the mix, we are going to choose which kind of process we are follow for this mixing procedure. It depends upon the how much amount and where the depth is located, how the soil properties are going to react. According to that, these are all the parameters we are going to understand for choosing the mix process. Now here, using a deep soil mixing rig to inject and mix the cement into the soil, ensure uniform distribution and proper mixing to achieve desired soil properties. Now we are move on to the quality control. Conduct unconfined compressive strength UCS tests on treated soil sample. Compare UCS values before and after. So pre-mixing UCS and post-mixing UCS for understanding the how much strength we are getting, how we reach the desired properties of the soil. So this kind of technology is helpful for understanding for getting the required desired properties of the soil properties for construction works. Now move on to the another type of technology, that is stone columns. This is also the technology we choose for getting the desired properties of the soil for the required construction work. In this, you need to improve the bearing capacity and reduce the settlement for a warehouse on silty clay. On silty clay, this is the type of soil. Stone columns are chosen as the improved method. So in this, here we are going to choose the stone column method. So now here the project warehouse foundation, soil type is the silty clay, column diameter is 0.8 meter, column spacing is 2.5 meters in a triangular grid, Depth of column is equal to 10 meters. The detailed solution and calculations, we are move on to this. So here the site assessment, any kind of technology, the first step we are doing, that is the conducting the test for understanding the what are the determined properties, soil properties are there. So we are understanding those properties and we are arranging the what kind of that particular technology is demands. So here in these stone columns, column arrangements and number of calculations. Calculate the area covered by the one column. So the area per column, that is equal to root 3 by 2 spacing square and root 3 by 2 2.5 meter square. So this is the answer, 2.71 meter square. In this, number of columns required for 1000 meter square area, this is equal to, finally we will get how many number of columns are required for this work, for the getting the desired properties. It depends upon the area and the how much spacing we are in between the things. So now move on to the installation process. As per the demand, we are choose this installation procedure. Use a vibro replacement rig to install the stone columns. Ensure proper placement and compaction of granular material. In this, the quality control will perform these tests for understanding the soil sample of columns to ensure the desired bearing capacity. So once we understand before, post and after conducting these application of the technology, this technology of the stone columns, once we understand the stone columns, once we application is done, so now we are understanding the how much variation in the bearing capacity we will observe. According to the, we are conducting the bearing capacity test before and after, we compare those two. Now, and one more technology, that is equal to geosynthetics reinforcement. In this, a slope needs stabilization. For a new road construction project, geosynthetics reinforcement, those are geogrids will be used to enhance the slope stability in this project. So road embankment stabilization, slope angle is 30 degrees, slope height is 10 meters, geogrid type is high strength polymer geogrid. In this, the layer is every 1 meter vertically. In this, the site assessment, conduct a slope stability analysis to determine the factor of safety. For this, we are understanding the geogrid installation. First, we are calculate the how many number of geogrids layers are required. So, from the formula, number of layers is equal to slope height to layer spacing, that gives the how many number of layers are required. After that, we move on to the installation procedure. In that installation procedure, excavate the slope to the required depth. Place geogrids horizontally at 1 meter intervals. Backfill and compact soil over each layer of the geogrid. So in this, the quality control. So for understanding all these parameters, we are going to conduct this geogrid installation. In this, first we are going to do we are excavate the slope to the required depth. The place geogrids horizontally at 1 meter intervals. So the backfill and compact soil over each layer of the geogrid, and conduct pull out and to ensure the proper anchorage of the geogrids. So perform slope stability analysis in post installation and pre-installation. We will get the difference between those two, we will understand. So in this particular, we are choose this technology. And also for this is the road construction work, and we are going to enhance the required properties, that is nothing but the slope stability. These are the parameters. According to that, we are choosing the procedure. So these are the some of the things we are going to observe in our mechanical modification. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.